Welcome back to the visual novel game series on Godot. This is part 3. If you haven't watched the previous parts yet, you might feel a little bit lost, but don't worry, you're still welcome to stick around. What you will learn in this video can be applied to any game's dialogue system, whether it's for a visual novel or another genre entirely. So to quickly recap, in the earlier parts we set out to recreate the iconic Ace Attorney game interface in Godot. So far we've made significant progress and we're now close to completing the core elements of the system. Here's what we will be covering this time. Instead of displaying the whole line of dialogue all at once, we'll make the text appear progressively, creating a more engaging and dynamic experience. To streamline our code and improve scalability, we'll create a character class. This will simplify the process of adding new characters in the future, making the development more efficient and organized. We will add some sound design to complement the animated text, specifically the text blip sound that makes the dialogue feel more alive and immersive. Now open Godot and without further ado, let's go. Time to animate our text the way it is done in Ace Attorney. As you can see here, the text has to appear progressively, character by character. There are multiple ways to achieve this effect, but Godot has something that will simplify our work by a huge margin. Inside the Dialog UI node tree, select the Dialog line node. As you can see in the editor, the Rich Text Label node in Godot has a property called Visible Characters, and another called Visible Ratio. If you play with the values here, you can see that they are doing exactly what we're aiming for, make the text visible progressively from beginning to end. You'll also notice that these two are tied because they affect the same aspect of the text. We are more specifically interested in visible ratio here because it controls the ratio of the text visible at a given moment. I'm sure you can see where this is going. We will manipulate this variable in our code to achieve the text animation. Jump back inside of the Dialog UI script. As I've mentioned in the second part, things that affect our game on a frame-to-frame basis should be coded inside of the process function, because its content is executed every frame. But before we go ahead and code the animation, we'll add 3 properties on top of our file that we will need to better control the animation. An integer defining the animation speed, which we'll put to 30 for the moment. As per the coding conventions, since this is a constant and isn't meant to change while the game is executed, the name is written in all caps. Then we have a boolean to decide if the text needs to be animated or not. Essentially, this boolean will tell us if the animation has been played already or not, so we can skip the content of the process function when needed. We will also add another integer to track how many characters have been made visible during the animation. This variable will be linked to the visible characters property of Rich label text that I've shown you earlier. In our visual novel game, the text should be animated when it is displayed first, in other words, when Dialog UI displayed a new line. Now, on part 2, we've already coded the part where Dialog UI is modified in order to display a new line of dialogue inside of the process current line function of the main scene script. However, it would be difficult for us to know when that happens inside the script of Dialog UI because it all happens in the parent node script. To make it easier for us to time our animation, we should move that part of the process inside Dialog UI since it affects its properties. But main scene still needs to tell Dialog UI when it should be done. This is where another core concept of Godot comes into play, communication between different nodes. The notion of signals comes into play here because they are typically used for this purpose, communicate an information to other nodes. But we won't use signals to do this. If you do not know about signals yet, don't worry because I will explain what it is a bit later in this video. For now, remember this general rule: call down, signal up. This refers to how you should be communicating between nodes depending on your node tree. Essentially, if the emitter is lower in the node tree, you'll use signals. If the emitter is higher, you'll want to use method calling. In other words, signals should not be used to communicate information to subnodes because it is not the way they are intended to be used. Instead, here, we need to call down, or in other words, call a method associated with the receiver or the subnode. Don't panic if you didn't fully understand all of this yet. I think it will become much clearer later in the video. Let's move that part of the process inside Dialog UI script so that we can time our animation better. Inside Dialog UI script, create the method called changeLine, which will be called when Dialog UI needs to actually change its line of dialogue. This is when we want to reset current visible characters and put the boolean animate text to true so that the animation of the next dialog line can start playing. Additionally, let's do what the method name says and change the line of dialog. We can now proceed with the process function. There it is. Now before you copy blindly, let's make sure we understand each line and what it is supposed to be doing. We already know that the animation is only played once, so process doesn't need to be doing things after our animation is done. For that reason, start with if animate text, so that we make sure everything that follows will only happen when the text needs to be animated. Remember that visible ratio is a float that goes from 0 to 1, 1 meaning that the entire text is visible. The text only needs to continue its animation if we didn't reveal all of the characters yet. If we did, that is when we can signal the process method to ignore this part of the code by putting animate text to false. Here, the text needs to be revealed slightly more than it was last frame. This fraction does exactly that. It ensures that visible ratio progresses from 0 to 1 over the length of the text. For example, if the text is 10 characters long, each increment will reveal 1/10 of the total. This part determines how quickly the ratio increases, which is why animation speed is there. You might be wondering, why is delta even here? Let's hide it for a minute. Like I said, process runs every frame. With our arbitrary value of 30, this would mean that visible ratio gets incremented by 30 units every frame. But imagine this scenario. Player 1 plays your game at 30 FPS in the settings, and Player 2, with a much more powerful computer, plays it at 60 FPS. With the current implementation, the text animation speed is tied to the frame rate. The animation would play twice as fast for Player 2 because the content of process would be executed 60 times per second as opposed to only 30 for Player 1. Obviously that's a big no-no. You want your animation speed to function the same no matter the frame rate. And this is where multiplying by delta helps us. For 60 FPS, delta would be equal to 130. For 60 FPS, delta would be equal to 160. So by multiplying animation speed by delta, we can make sure that the speed is adjusted to the frame rate. If you play the game at 30 FPS, this product equals to 1, meaning visible ratio is incremented by 1 every frame, or 30 units every second. If you play the game at 60 FPS, this product equals to 0.5, meaning visible ratio is incremented by half a unit per frame, or 30 units every second. In conclusion, multiplying by delta allows us to tie our speed to the elapsed time, in seconds, and not the frames. This is very important for any sort of animation you might want to add. Finally, update current visible characters with a new value now that we've incremented visible ratio. If you look back at what's happening in main scene, you'll notice that we forgot to do one thing. When the line of dialogue changes, the speaker name should also be updated. Change the changeLine method accordingly. Now that changeLine is doing what we need it to be doing, we can erase this part of the code inside process current line and simply call changeLine. This is what calldown means. We're calling the method of a node located lower in the tree. Let's try and execute our game. Unfortunately, no animation to be seen yet. Why? Look back at the changeLine function. Current visible characters is indeed set to 0, but the property it is supposed to be tracking, visible characters, isn't. Make sure that visible characters is set to 0 as well, and if you execute your game now, you should finally be able to see the text being animated. Nice! Now in a visual novel, when the player taps Enter, Space, or any button that you have configured for next line while the current line of dialogue is being animated, you don't want to display the next line of dialogue yet, because the player might not have seen the entirety of the current line. Instead, you'll just want to skip the animation of the current line of dialogue. Let's do this. In the main scene script, inside Input, add the following section. Skip text animation doesn't exist yet, but we will add it now. Inside Dialog UI, create skip text animation as such. You want to display the entire text, so visible ratio is set to 1. You do not need to bother assigning animate text to false, because it will automatically be set to false on the next frame. Execute your game once more and verify that the next line input skips the animation instead of displaying the next line. Nice! So far so good. Now that we have a way to know when the character is done speaking, we can do what we couldn't do in part 2 and switch to the idle animation when the text animation is completed, so that the speaking animation doesn't play indefinitely. Now who knows when the text animation is completed? Dialog UI, right? Thanks to its properties. But who needs to know when the animation is completed in order to change the character sprite? Main scene, because this is where we are switching the sprites. In other words, Dialog UI, a subnode of main scene, needs to communicate something to main scene. We're going up. Looks like it's time to use signals. Here's how we do it. In Dialog UI, create a signal named animation done. We need to fire the signal when the animation is done, right? That happens exactly here, when visible ratio reaches 1 and animate text is set to false. You'll call the internal emit method of your signal to do so. At this stage, the signal is fired, but no one is listening to it yet. As I mentioned earlier, main scene needs to know when that signal has been fired, and here is how we'll proceed to do so. Inside the ready method of main scene, we need to tie the signal of Dialog UI to the method that will perform the character sprite change. You do this with the internal method connect of your signal. The onAnimationDone method doesn't exist yet, but we will create it now. If you're wondering why I'm calling in this way instead of change character sprite, for example, it's because this is the Godot convention for methods connected to signals. They're all called onSignalName. Godot has a lot of predefined signals associated to its nodes, and you can actually see their list if you click on the Signal tab of a specific node. Inside of onAnimationDone, we need to tell character node to switch to the idle animation. We could do it here, but to stay clean, let's mimic what we've done right above inside process current line, and do that part of the process inside the script of character itself. Inside the character script, create the method called playIdleAnimation. The implementation should be fairly straightforward here, and once that it's done, you can call your new method inside main scene. I'm renaming my signal to textAnimationDone because I noticed the name could lead to confusion. Execute your game. Now our characters stop speaking when the text animation is done. Awesome. Let's continue. You've probably noticed it by now, but when executing your game, the scrolling feature of Godot's rich text label is displayed automatically when the text gets a little bit long. If this is the behavior you want for your game, you can feel free to leave it like this. And for me, however, as I want to replicate Ace Attorney, I'm going to go ahead and deactivate it in the inspector of rich label text. Instead of having scrolling feature, I will simply make sure that my lines of dialogue do not exceed a certain length. Now let's discuss game characters. As it stands, we have defined information pertaining our characters inside of the script of character node, which isn't very pretty because this is a game node, or a UI element if you will, and these things are all game data. They are immutable things that aren't best defined inside of a UI node script. Instead, nodes should access this data when needed. It's high time for us to have a character class, which will represent each of our characters and contain all of the information related to them. Let's do that. Before anything, rename the character node to character sprite, so it's easier to make the distinction between this and what we're going to do next. Create a new script file named character with a capital C, since this is not a node script but a class. This class will contain the information for all of our characters. There are several ways you could implement this kind of class, and all of them depend on what else is in your game, but I'm just going to show you the way I did it. Go ahead and create an enum with the name of our characters, along with a method to actually get the enum out of the character name in string format. At this point I'm not sure if I will need this method, but I tend to add it just in case when creating enums. You might be wondering why representing our characters with an enum. Well, there are several reasons for that. One reason is that using an enum ensures that only predefined character names are used throughout the code, reducing the chance of typos and errors caused by hard-coding strings. Another reason is that adding or modifying a character becomes way simpler. You only need to update the enum. By using the enum values instead of raw strings or integers, the code benefits from additional type safety. For example, the getEnumFromString function ensures that the input string corresponds to a valid enum value. Another reason is that enums in Godot can be integrated with the editor for features like drop-down lists in the inspector, allowing easier selection and less manual input. Additionally, with the dictionary that I am adding right now, the enum along with the character details dictionary allows us to centralize character-specific data, making the code cleaner and less prone to duplication. Since we now have a place to put character data, let's move the information about the character sprite files here as well, so they can be removed from character sprite node. Remember, preload is a function that runs at compile time and not runtime, so it will be called only once and not every time we are trying to access this resource. So it's completely fine to have it here. Since Apollo does not have sprite frames, we will simply write null. We can now change the method changeCharacter to use this new dictionary as such. This allows us to replace the very ugly and hard-coded if character name is Apollo with a much better if sprite frames, to test for the existence of sprite frames for the character speaking. This previous line wasn't ideal because referencing your character directly with its string value like this is considered bad practice, especially now that we have an enum to reference characters. If you decided to change the name of your character in your script, that line of code wouldn't have worked anymore. Now with our new logic, not only the protagonist, but any character in your script that doesn't have sprite frames will work as intended. If the new speaker has sprite frames, we will switch to their talking animation, and if not, we will simply display the idle animation of the character currently displayed. You can finally erase the character sprites constant dictionary here as we don't need it anymore. To follow with this, let's change every utterance in our code where we use the string to represent a character name. We will use our new character class instead. Change process current line of main scene to the following. Change line of dialog UI to the following. With this, we ensure that whatever gets displayed in our speaker box is a valid character name. Executing our game gives us one error. It seems that character here refers to null. That's because we renamed the character node to character sprite, but we forgot to update its reference on top of the main scene script. Let's update it, renaming it character sprite as we go, and change the rest of the code accordingly. We have another error, trying to get a return value of a method that returns void. So I actually understood where this was coming from right away because it's from this line of code right here. It's a one-liner with an if and else condition, which probably stems from my Python habits. I wasn't sure if this worked the same way in GDescript or not, but I have my answer now. So change it to a proper if and else condition, and we're good to go. The game works the same way as it did before, but now our code is easier to maintain and more scalable. Let's move on to the last part, sound design. In Ace Attorney, while the text is being animated, you can hear these text bleeps playing. The text bleeps can also differ based on the character. In our case, we'll have one text bleep for male characters and another one for female characters. This is also why I've added the gender information inside of the character class. You can find the assets linked in the description as always, but truthfully, you could use anything you'd like. You can give your game a very different feel by using different sounds, so I do encourage you to try a few things. Now looking at Ace Attorney, at first glance it seems like there's one text bleep per character displayed, so let's try and do that first. Right-click on Dialog UI node and add what we call an audio stream player. This is what's used in Godot to play sounds. If you look at the editor, they have a stream property, which is where you will insert the sound to be played. Since there are no UI elements, their position in the node tree doesn't matter as much, but I like to move them on top. Rename it text bleep sound and attach a script to it. We won't need ready or process, so feel free to erase them. As I've said, we have one sound file for male and one for female. Just like the character sprite animation files, these files need to be preloaded before they can be used. Create the method to play the sound by attaching it to the stream property and calling play. Naturally, we need to know the gender of the character first, so this method will take the character name as an input, from which we can find the gender using our character class. Now that it's done, jump back to Dialog UI script and make the audio stream player accessible on top. As I've said before, we want to try and play a sound every time a new character appears. Looking at the process function, we know that a character does not appear every frame, because that would be too fast. Unfortunately, looking at visible ratio doesn't really help us in knowing if a new character has been added or not. But this is why we've added current visible characters, which instead tracks the visible characters property. We want to play a sound whenever visible characters became larger than current visible characters, because that means at least one more character has appeared since the last tick, and here's how you do it. Now, play sound need information about the character speaking, namely the character name. Add a property on top to track the current character details, and to make sure the change line modifies it accordingly. Now, instead of providing only the name in playSound, we're going to go ahead and give it the full character details, so that we don't have to infer the details back and find the gender inside of it. Change playSound as such, which makes it a bit simpler. Now I'm realizing now during the editing that we are using the word character to refer to string characters and also game characters, so I apologize if any of you got confused during the process. Feel free to rename some of these variables if you wish to do that. Before we start executing our game again, you may have noticed that Ace Attorney doesn't actually play a text bleep for every single character. Characters that are not pronounced, such as a dot or an exclamation mark, appear silent. Add a constant list of characters that won't produce sounds on top, and change process so that it doesn't play a sound for these special characters. Executing our game now leads to an error, telling us that play does not exist. So here I mistakenly thought that play was a method inside of the stream object, but actually it's just simply part of the audio stream player node. So calling play will play the sound associated with the stream directly. Change the code as such and execute your game again. Congratulations, you've added sounds to your game. However, listening to it now, it's pretty obvious that the sound plays way too frequently for one line of dialogue. It's actually a little painful to listen to. My assessment that Ace Attorney played one text bleep per character was visibly wrong, but no big deal. We're going to fix the frequency of the sound ourselves. We can do that with some sort of timer. We can assign a certain duration to this timer, for example 0.5 seconds, and every time that timer reaches 0, we play the text bleep again. This will give us better control of our sound frequency, which is a better alternative than having it tied to the dialog characters. Fortunately, Godot has timer nodes natively. Add a timer inside dialog UI, move it on top and rename it as such. Make it accessible inside the code, just like we did for the sound. Let's put it to 0.09 seconds for now. If you only needed this timer to be used once, you would check the one-shot property here, but since we need our timer to loop for as long as our text is being animated, we will leave it unchecked. Inside changeLine, start the timer. Now, when do we know when the timer reaches 0 inside of dialog UI? That's a situation where timer, a subnode of dialog UI, needs to tell dialog UI something, right? Some of you might have guessed it already, but this is a textbook example of signals. Only this time, we do not need to create it ourselves, because if you look at the Signals tab of the timer editor, you will see that the signal we need already exists inside of Godot. That said, we still need to tie the signal to the act of playing the sound. Inside Ready, connect the signals to onTextBleep timeout, which we will create immediately. The only thing it needs to do is, well, play the sound. You can then remove that section from the process method, since the sounds are now handled independently from the text. Execute your game. The frequency is indeed better, but now the sounds never stop playing. That's because our timer keeps looping in the background and we haven't told it when to stop. Inside Process, where our animation is done playing, which is here, add this line of code to stop our timer. Execute your game again to witness a much better sound design. Let's polish it a little further. In Ace Attorney, the game characters actually pause a little bit before each sentence, which adds a nice touch of realism. In our game, however, the whole text appears character by character without stopping until it reaches the end of the dialogue line. Let's change that. We need to define for how long a character should stop speaking between each sentence. That calls for another timer, which you'll create inside dialog UI and rename it as such. As always, make it accessible as unique name and add it to your script. It's a good thing we already have end of sentence markers defined here because we can use them to know when to start our timer. Inside Process, let's rename this variable current character. Let's make sure that we didn't reach the end of the dialogue line, because in that case we wouldn't need to start the sentence pause timer. Let's check that our current character is a punctuation mark and optionally that the next character is a space. Inside that if condition, we need to temporarily stop our text bleep timer and start the sentence pause timer. Connect the timeout signal of sentence pause timer to a method called onSentencePauseTimeout, and inside of it you can resume the timer for the text blips. Execute the game and immediately you can see that while the text blips do stop, the text animation does not. Not an issue though. Inside Process, add a condition to check if sentence pause timer is stopped or not before we animate our text. Timers have the very useful native method called isStopped for that purpose. Execute your game again and let's see. Great! Lastly, we will add one more sound that will be played when the player goes on to the next line of dialogue. The input for this happens inside main scene, so create an audio stream player inside main scene and rename it to next sentence sound. Add it to your script and simply play the sound when the player goes to the next line of dialogue, which happens inside input, specifically here. Let's execute our game one last time to see how far we've come. If you want to polish this a little further, as homework, you could try to add a little bit of time before the next sentence is displayed, to give the next sentence sound a little more room to be played. And this is the end of the video. If you're still here, you should be proud, because the YouTube statistics are telling me that most of you guys don't make it to the end, unfortunately. With everything we've covered, you should now have a solid foundation to take your visual novel in any direction you'd like. This is actually as far as I've taken the tutorial project myself, and I don't have a part 4 ready yet. I'm also not sure if I'll be making one really soon, but if you would like to see this series continue, please let me know in the comments. You can share what you'd like to see implemented next. For example, we could try to add the player choice during the dialogue, or I've heard someone mentioning speech bubbles instead of like a text box. Or we could also try to go back on the scripty language thing I've mentioned in part 2. Decision is yours. In the meantime, I plan to try and post some short format videos on my channel, mostly related to 3D modeling in Blender, so I do hope you'll stick around. Maybe we can even connect Blender and Godot one day and make assets for a game. Thank you for watching, and I'll see you in the next video.